Hey, Algebra 1, jumping back in with part 2. So let's jump in with number 7. Write the y-intercept for the equation. And the first thing I notice is that the first equation is in what we call standard form versus the second equation is what we call slope-intercept form. And so some people would approach A where it says write the y-intercept for the equation. I've already set up, a point that represents that y-intercept. And the y-intercept is when you plug in 0 for x, and so that's actually more of the way that I did it instead of trying to solve for y to change forms. That's fine, you can do it that way, it'll work out perfectly. Identify the b value in the y-intercept form when you solve for y. But I wanted to kind of think of it as, well, if I know that the y-intercept lives when x is 0, I'm all about input-output here, I want to plug in 0 for that 8x part. So if you start by plugging in 0 for the x, 8 times 0 is 0, and so basically it's like you only have this second part of the equation. If you are in my class, I call this like the cover method. You kind of cover the 8x because you're plugging in 0, and then we're going to solve by dividing that 3 to the other side, getting y by itself, solving for y being -8. So now I know that 0, -8 represents that y-intercept. Again, solve for y if you want, and you will, I think you get, let's see, -8/3 x minus 8, and that minus 8 is your answer. But let's look at B. It says write the equation in standard form. Standard form means I'm trying to basically get x and y on the same side where they're adding together. And I put that A in green because this is like your top level trivia here. When you're solving for something in standard form, that A value, that coefficient of x is always positive. It's just a rule. Google it. You'll see that that's a rule for standard form. And so I want to kind of walk through these 3 steps that will allow me to get that x to the left side correctly, but also allow me to have it in the correct form where that value is positive. Again, there's more than one way to do problems like this. So the first thing I wanted to do is I wanted to get rid of this fraction, so I just multiplied everything by 3. That gave me 3y on the left. And when you multiply something by 3 that has a fraction that already had a divider of 3, well, 3 divided by 3 is 1, and that leaves you with 1 times 2, which is just 2. And so that's a quick way. That's why I chose to multiply by 3 here, is because it would eliminate the variable, or eliminate the denominator, sorry, with the variable of x. So then you also have to multiply -4 times 3, which some people would just forget to do that, and then you have not correctly multiplied everything by 3. So the next thing I want to do is start trying to get that x term to the other side. So I want to subtract that 2x to the other side. And some people may have written 3y minus 2x, but again, I'm trying to get the standard form where it's x, then y, and then a constant on the other side of the equals. So I chose to put the -2x in front of a positive 3y from the original left side. Well, on the right side, this is leaving you -12, and it looks like it's in standard form. I mean, some people would say this is fine. You've done it. But if you're really trying to make sure that it's perfectly correct in a mathematician's world, we really need this value to be positive. Well, if it's negative, just multiply it by -1 and all of the signs will change. And so that's the last thing that I do here, is I just say, well, negative changes to positive, and a positive changes to a negative, and a negative changes to a positive, and now I have my final answer. It's in standard form. So this next part, complex solving for Algebra 1, you're distributing a fraction here. You've got variables on both sides. So this is not just a 1 or 2 step problem. In fact, I use 5 steps to do it. So let's walk through what those steps are. The first thing I look for in problems like this is that distribution. Half of 16x would be 8x, and half of 5 would be 2.5. And you may use a fraction here, just putting 5 over 2, but just because it's harder to do this on my laptop, I just left it as a decimal. It's perfectly fine. And then I just rewrote the rest of it where it's not changing. I didn't want to multiply 1/2 past that parenthesis after the 5. So now I want to simplify that 2/2 minus 3, and I don't want to change the operation because they're on the same side, and that would just give me -0.5. Again, a lot of things around it not changing. And so now my goal is to kind of balance the equation a little bit. I want to put the variables together, and I see 8x on the left, I see -5x on the right, and so I chose to add 5x to both sides. That will allow me to just cancel this side, and it's slowly kind of putting terms together that need to go together. And a lot of other things falling unchanged. Minus 0.5 equals 19. But of course, 8x plus 5x is 13x. Well, similar in the balancing equation part, kind of like you'll do in chemistry, I'm trying to kind of put things together that need to go together. And this value is a like term with this value. 0.5 and 19 are both constants. They need to go together. So I chose to add 0.5 from the left to the right, which I didn't show, but sorry about that. Just explaining it here. And then that last step, I need to divide that 13 over, and that leaves me with 1.5, and as a fraction, that could be just 3 over 2. So either value is the same for your answer. And that's the value of x, that if you were to plug that in over here on the 16x, if you did 3/2 of 16 and you did all the math on the left side, if you also did that over here, plugging in 3/2, both of these would come out to be the exact same. They would be equal whenever you plug in that value. So number 8, we are shifting, or what they call translating or transforming linear equations here. So for each of the following, a function has been given along with its graph, and perform that specified transformation on the function and graph. So the first thing I notice is it says it's 2x plus 1, and I just double check that that was correct. It starts at 1 and it goes up 2 over 1, and that's what we have for f of x. Now, what this is asking us to do is basically subtract 3 from whatever you get when you plug in a value in for x. Whenever you're done with all of that, you multiply by 2, you add 1. After you do all that, we'll just subtract 3. And that basically, what that does is that just takes your line and lowers it, decreases all of the output values by exactly 3. So we kind of look at that and say, well, we're going to call that a shift down 3 units. Basically take every point and just shift them down 3, and that will represent the exact same function. Or a new function, rather, that is this f of x minus 3. So now it's asking you to do part B, and it's saying, well, let's make it a little different. Let's dilate it. Let's reflect it. Let's do 2 actions. Let's multiply it by 2, and also that negative represents this idea of reflecting the graph. It was a positive and now it's negative. And so the way that I approached that is I said, well, if the original function f of x was x plus 5, well, let's just distribute negative 2 throughout that whole expression, and you get this new equation, or a new expression, this new graphable situation, negative 2x minus 10. And so I went ahead and said, okay, well, that negative 10, that represents the y-intercept, this very bottom point here. And that's, again, input-output is how all graphing works. So if you were to plug in 0, negative 2 times 0 is 0, 0 minus 10 is negative 10. Now, if I was to plug in negative 1, for example, negative 2 times negative 1, well, that's positive 2, and 2 minus 10 is 8, and so, or negative 8, rather. And so I wanted to plot a few of these points, and that allowed me to draw my line right over those points. Excuse me. And so you could have also used that slope. We see that slope is negative 2, and so it won't allow you to go down 2 and over 1, but that means you could reverse it and go up 2 and left 1, up 2 and left 1, and then you'd have all of these other points that you could start using that common trend of. You have your graph. Solve the compound inequality and represent the solution on the number line. So they give us a starting compound inequality. The word compound means more than one. Like in chemistry, you have compounds where you take elements, more than one element, and put them together, like H2O. Similar idea here, but what we're compounding is inequality signs. So there's 2 inequality signs that are given in the problem. And so the first thing I want to explore was taking that middle part and saying, well, instead of adding 4 to the x value, I want to subtract 4 out of there. And that means that I would have to subtract 4 to both sides. And this is slowly, what it's doing is it's allowing me to figure out, well, what is just x? Like the value of x is between what 2 numbers? So I'm trying to basically undo the middle. And when you subtract 4 from negative 2, you get negative 6. 16 minus 4 is 12. And this 3x, again, when you see a number written as a coefficient, they're like crammed up against each other, 3x or 2y. That's multiplication, and so 3 is multiplying against x. Let's divide by 3 out of the middle, and that allows me to understand like -6 divided by 3 is -2, or 12 divided by 3 is +4. And so now that allows me to go and graph the inequality using these closed points, going to -2, going to 4, and then we're basically saying x is a value that does both. It's a value that's greater than -2 while also being less than 4, and that those little lines at the bottom allow you to be equal to those numbers. And so that's why I want to fill the point in saying that, hey, -2 is included in the solution and so is +4. And just to throw it out there, if that had not been there, if that line had been absent, I would not have done a closed point. I would have done, just to make it simple, just do an O there, I would have done more of an open point there to kind of represent that my solutions go all the way to that number but don't include that number. And so that's what you should look for if you ever see that you don't have that or equal line. So this next problem I want to look at, it says Samuel's paying so much plus 25 cents for each minute. So it's a very similar problem as the one we just looked at a moment ago. But in this case, if you read both of them, basically these are specifications for 450 minutes for each of their phone plans. Since they have both of those things in common, it's not really important for me to use that in A, B, C, or D here. But it is important to them and based on how the whole plan works. So again, I want to lock in on what needs multiplication. What is just a constant value in the price plan. So for Samuel, it looks like he's paying this fixed price, $59.99, plus so much for each minute. And based on that last problem, that per minute part, that needs to have a variable with it. So when I'm looking for an answer down here, I really don't want to look for 59.99x because they gave that first in the problem. That's not really how you answer the question here. I'm more looking for that 25 cents that's connected to a variable that needs that multiplication. So I see 2 here that are doing that. Well, I need to kind of look for that similarly with the second one, 10 cents each minute. And so, okay, there's 10x, and okay, there's 10x, and that's all good. But which one of them are correctly mapping the fees to the right value? $59.99 should go with 25 cents. It's this one. Similar, $64.99 goes with 10 cents. So I know that's tedious there, but we're trying to make sure we have the right variable with the right value, also the fee with the right rate in terms of per minute. I've got time for a few more. Let's look at the next one. It says graph the system of equations and then determine the solution. So this one's a little tedious because you've got to move a lot of stuff around. You got to find this point of intersection. And so the first thing I wanted to do is take that first equation and try to get y by itself. When you solve for y, it allows you to graph the equation a little easier. So I decided to subtract 10 to begin the problem, and then I divided everything by -3. So that did have a sign change for my y-intercept. And so we'll graph that here in just a moment. Similar with the second equation, wanted to start by trying to get y by itself. So I started by subtracting 3x to that other side. Now they're not like terms. You may have noticed when I moved 10 in that first one, I didn't actually do 2 minus 10. Same thing here. When I subtract 3x to the other side, I don't want to make that 2, because I subtract. They have to both have the x, or they have to both not have the x for them to go together. That's what we call like terms. And then I want to divide by 2 by everything. And so I wanted to just kind of show you what that graph comes out to be, because you are starting at kind of approximated y-intercept values when you graph this, but they do intersect at the point -1, 4. If you were to plug in -1 for the x in either equation, your y value is going to come out to be 4 exactly. So, all right, so that's the end of part 2. I'll see you on part 3.